Hello my dear students, welcome to IMS GATE Academy. Excellent practice question series on communication subject. So in the earlier sessions we have discussed various questions regarding amplitude modulation, DSB-SC, and even in this particular session also we will discuss further questions regarding DSB-SC, right? So those who have attended earlier sessions, they can easily solve the questions that we are going to discuss in this particular session. Okay. So due to any reason, if you have missed few sessions earlier, so kindly watch those sessions in your free time, right? So this topic is also common for two branches, EC and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session, right? So I hope all of you are eagerly waiting for the session. So let us start. So this is a question asked in GATE EC 2004 for 2 marks. This is a question asked in GATE EC 2004 for 2 marks. So all of you read the question carefully and just look at the block diagram and you can choose the correct option. This question is MCQ. Obviously one of the given choices will be correct. So try to choose the correct option. This is a very interesting question which is asked in GATE EC 2004. And for solving this question, what are the knowledge required that we have already discussed in the last class also, few questions we have discussed. So first of all, read the question. Here you are having one system. So regarding that, they have mentioned the block diagram. Here you are having x of t is the input, and this is the modulating signal or message signal, and you are having the carrier signal which is having the frequency 10 kHz. So these two signals we have given as the input for balanced modulator, so it will produce the DSB-SC signal, right? So after that, that particular signal they have passed through the high pass filter which is having the cutoff frequency 10 kHz, and now whatever the signal that you are going to get at the output of high pass filter, that one we are giving as one of the input for balanced modulator, and the other input is you are having the carrier signal which is having 13 kHz. Okay, now the final waveform that you are going to get here, right? So in this particular waveform, the question is here, if you observe regarding the x of t signal, the corresponding frequency spectrum they have given. That is the x of f, capital X of f. Okay, so here it is starting from 0. Okay, if you observe the positive frequency axis, it is starting from 0 and up to 3 you are having 0 to 1 it is raising, and from 1 to 3 it is falling. Okay, just for symmetrical purpose. Okay, so while you are drawing the waveforms regarding the spectral components, just for symmetry we used to draw like positive x-axis if you are having, similarly negative x-axis you will be having, right? So in the same way, positive frequency axis you are having, similarly negative frequency axis. Okay, but for analysis purpose, okay, if you want to do, you can do only by considering the positive frequency spectrum. If you want, you can consider similarly you will get on the negative frequency axis also. Okay, right, but practically frequency never be negative, right? Always frequency should be positive. Okay, right. So now the question is regarding x of t. Initially, if you observe the corresponding Fourier transform or frequency spectrum, you are having at 1 kHz, you are having the peak value. Yes or no? At 1 kHz you are having the peak value. Okay, now the question is here at the final output waveform you will get, okay, in the frequency spectrum, in that particular spectrum, at what frequencies you will get the peak value? That is the question. Just read the question, continuation. Here you are having two signals, x of t and y of t. For overall block diagram, input is x of t, and the final output is y of t. The corresponding Fourier transforms are capital X of f and capital Y of f. Okay, time domain signal and the corresponding Fourier transform representation they have given, right? Now in this particular block diagram you are having high pass filter, that is the ideal one, and it is having the cutoff frequency 10 kHz. Now just read the question. The positive frequencies where y of f has the spectral peaks. At what frequencies you are getting y of f? Okay, regarding y of t, if you are representing the Fourier transform or frequency spectrum, in that particular frequency spectrum, at what frequencies you will get y of f is having the peak value or maximal? That is the question. Okay, so regarding that you are having 4 choices. You can choose the correct one. Okay, right. So what is the block diagram they have given? I have copied here. Now regarding for solving this question, what is the approach we have discussed in the last class? Okay, we have discussed total 5 questions we have discussed in the last class, right? In that initial question we have discussed with the help of mathematical approach, and then later so other questions we have discussed directly. Whatever the conclusion points are there regarding DSB-SC, those conclusion points we have applied. So we have solved good number of questions, right? I hope all of you got the good command over the DSB-SC signal. Right, now the same concept. You no need to draw the waveform at all. Without drawing the waveform, okay, whatever the question they have asked, you can answer. Okay, but you can solve whatever the approach that we have discussed in the last class, same approach you can follow. Right. So here initially if you observe regarding x of t, the corresponding Fourier transform is capital X of f, and consider only the positive frequency axis. Consider only positive frequency axis. Here you are having the spectrum lies from 0 kilohertz to 3 kilohertz, right? So that means regarding message signal, the corresponding frequency we are operating from 0 to 3 kilohertz. 0 to 3 kilohertz. In the last class also we have discussed. Initial question we have considered only one operating frequency, and other question we have considered like two operating frequency, and some of the questions we have discussed like over a range of frequency, right? So this question is also like over a range of frequency. Here from 0 to 3 kilohertz we are operating this particular signal, modulating signal or message signal. Now here you are having two balanced modulators. For the timing I will label this one as 1, this one as 2, okay, and here you are having 10 kilohertz, okay. So for the timing I will label, because for the first modulator, since you are having two balanced modulator, for the timing I will label this carrier frequency as FC1 as 10 kilohertz. FC1 as 10 kilohertz. So in the last class we have discussed, whenever you are having multiplier or balanced modulator or product modulator, okay, which is having two inputs, one input is a modulating signal, other input is a carrier signal, right? So at the output you are going to get two possible frequencies, right? So those are nothing but addition of these two frequencies and subtraction of those two frequencies, right? So output of balanced modulator 1, output of balanced modulator 1, so here we will get two frequencies. One is FC plus FM. Here I have assumed FC1, so you can consider FC1 plus FM. And similarly one more frequency you will get, that is FC1 minus FM. FC1 minus FM, right? So here FC1 is 10 kilohertz, okay. Whatever the range of frequencies you are having regarding FM, so just you have to add, that's all. So 10k plus 0 is nothing but 10k. 10k plus 0 is nothing but 10k, and 10k plus 3k is nothing but 13k. So that means here we are having 10 kilohertz to 13 kilohertz. 10 kilohertz to 13 kilohertz. So this is one sideband. This is one sideband, right? Next, FC1 minus FM. Or FC1 minus FM. So that means 10 minus 0 you are getting 10, 10 minus 3 is 7, right? So here you are getting 7 kilohertz to 10 kilohertz. 7 kilohertz to 10 kilohertz. Now you can observe overally from 7 kilohertz to 10 kilohertz, that is one sideband, and from 10 kilohertz to 13 kilohertz you are having other sideband, right? So here 10 kilohertz is nothing but the carrier frequency, right? So the carrier frequency is at center, and to the right of it you are having one sideband, to the left of it you are having another sideband. So here you are getting two sidebands and carrier is suppressed. Carrier suppressed means at carrier frequency you don't have any signal strength, okay, right? So here at first balanced modulator you are getting two possible frequencies, okay. Here one range of frequency you are getting 10k to 13k, another range of frequency you are getting 7k to 10k, right? Now here we are using high pass filter. High pass filter, as the name implies, it will pass only high frequency signals, okay. And here you are having cutoff frequency 10 kilohertz. Cutoff frequency 10 kilohertz. So that means starting from 10 kilohertz all the above frequencies it will pass, right? So just observe these two frequencies, which range of frequencies this particular high pass filter will allow. Yes, obviously the first one. Yes or no? Here you are having range of frequencies starting from 10k. Here the range of frequencies below 10k, right? 7k to 10k, those are less than 10k, right? So at output of high pass filter, we are getting only this range of frequency, 10 kHz to 13 kHz. to 13 kHz. Now we are having once again same balanced modulator, but here the input signal range you are having like this. Initially you are having like 0 to 3K, but now you are having the range 10K to 13K. Okay, and here balanced modulator, it is having the carrier frequency as 13 kHz. Okay, so in this case FC2 is 13 kHz. FC2 is 13 kHz. Now output of balanced modulator 2. Output of balanced modulator 2. So here also you will get two possible frequencies. One is FC plus FM, but here FC is nothing but FC2. And here for the original signal, modulating signal, you are having FM, okay, but for the timing, suppose I am labeling this 10 kilo to 13 kilo. For the timing, I am labeling as suppose F suffix C. Okay, so here you will get FC2 plus FA, FC2 minus FE. See, whatever the two signals that you are giving for the balanced modulator, at the output you will get addition of these two frequencies and subtraction of those two frequencies. Similarly, here also you are having balanced modulator, addition of these two signal frequencies and subtraction of these two signal frequencies you will get at the output, right? So here first of all you can add 13 plus 10, that means 23. 13 plus 10, that is 23 kilohertz to 13 plus 13, that is 26 kilohertz. This is one band of frequencies, 23 kilohertz to 26 kilohertz. Now you have to subtract. 13 minus 10, you will get 3 kilohertz, right? 13 minus 13, 0. So that means we can write 0 to 3 kilohertz. Okay, so here you are getting two range of frequencies. Okay, 0 kilohertz or 0 hertz, both are same only, because when you are multiplying 0 with anything, you will get simply 0, right? Okay, so you are getting one band of frequencies starting from 0 and up to 3 kilohertz. Another band of frequencies you are getting starting from 23K and up to 26 kilohertz. Okay, so if they have asked regarding the final output, at what frequency range, okay, you are going to get the signal spectrum, then this is the final answer. But now see the beauty of this question, they haven't asked that one. What they have asked, whatever the frequency spectrum you got, now you got two band of frequencies. One is from 0 to 3 kilohertz, and other one is 23 kilohertz to 26 kilohertz, right? So now the question is, at what frequencies we are having regarding y of f, where we are getting the peak value? That is the question. All of you just guess. You are having 4 choices. Can you guess which one can be the correct answer? See, if you don't know which one is the correct option, at least At least can you eliminate out of 4 choices for this question? Out of 4 choices, you can eliminate 2 choices. At least can you eliminate 2 choices? See, just observe the band of frequencies that you are going to get. With the help of this one, you are getting y of f exists from 23k to 26 kilohertz, right? You are having 23k to 26k, right? So just observe here, within that range 23 to 26, you are having 24, okay? You are having 24 kilohertz, whereas here you are having 14 kilohertz, right? So that means option C and option D you can eliminate. Option C, option D you can eliminate, right? Okay. So for this question, if you don't know which one is the correct option, but at least you can eliminate the wrong answer, okay? So for this question, luckily you can eliminate 2 choices. Luckily you can eliminate 2 choices, okay, right? So now 2 choices are left over, okay? Among option A, option B, regarding 24k, it is same in both the choices, but here you are having 1k and 2k, 1k and 2k. Yeah, some of you used to guess option A as the correct one, but that is not correct. That is a trap in this question, okay? Option A is not correct. Why? See here, if you want to understand, or suppose for this question, whenever you are attempting, most of you used to draw the frequency spectrum, okay? But we haven't drawn anything, because without drawing the waveform also we can easily answer the question, okay? That is the reason I haven't drawn. If it is required, we can draw, okay? Of course, even if you draw also, it will take more time. Definitely you will get the correct answer, but it will take more time, okay? But how easily we can attempt the question, that is, for that I am explaining here, okay? So that what are the shortcuts here we are discussing, okay? If you are able to follow these shortcuts in your GATE exam, you can easily solve most of the questions in less time, right? Because ultimately in the GATE exam, you have to answer most of the questions correctly, and not only that, you have to attempt the questions in less time, right? So that if you are able to attempt the questions in less time, so that you can score more marks, right? That is the main intention, okay, right? Now some of you might have chosen option A as the correct one, but that is not correct. The reason is very simple. Just observe the original waveform. Just observe the original waveform. Regarding x of t, the corresponding frequency spectrum, you are having x of f, right? So just if you carefully observe, from 0 to 3 kilohertz, you are having the frequency spectrum regarding the x of t signal, right? Now when you have observed from 0 to 3 kilohertz, right? So you are getting the peak value, at only one frequency, that is nothing but 1 kilohertz, right? So here the range of frequency is the 3 kilohertz, or you can say this band of frequency is 3 kilohertz. Within that 3 kilohertz band, starting from 0, okay, here center frequency is 0, or starting frequency is 0 for this particular band of frequency. When you have considered the band of frequency starting from 0 to 3k, for this given diagram, you are getting the peak value at 1 kilohertz, So that means from this 0, after 1 kilohertz, you are getting the peak value, right? Now carefully if you observe, here you are getting one band of frequency, right? 23 kilohertz to 26 kilohertz, right? 23 kilohertz to 26 kilohertz. So starting from 23k, so if you are adding 1, there you will get one peak, 23k plus 1k. So that is nothing but 24k. So we are getting the peak value of y of f at one frequency, that is 23k plus 1k, which is nothing but 24k. So obviously here if you observe, option A, option B, both are having 24k. Right? Now same logic, some of you might have applied. Because of that, here starting frequency is 0, so 0 plus 1, that is nothing but 1, right? So because of that, some of you might have chosen option A, but that is wrong. That is wrong. Why? Any guess? Why option A is not correct? Any guess? This is an interesting question. That's why I have mentioned, starting from this particular session, I have mentioned regarding this question, it is a very, very interesting question. The reason is here, because generally students in hurry, they will choose option A, but that is not correct. That is not correct. And intentionally, okay, if the question paper setter is so expert, then they will keep whatever the students, if they do silly mistake, okay, because of that, what is the possible answer they will get, that particular option they will, that particular answer they will keep in the first choice. Because in the exam in hurry, if you are not focusing on the basics, okay, or if you have not focused on the main point, whichever is required, okay, if you have missed that one, then it is like, just like in the cricket match, okay, if the whoever batsman, okay, if he is not focused, okay, so whatever the ball, okay, if he suppose he has to skip that particular ball without hitting, okay, instead of that, if he simply hit, it may go for catch out, right? So like that, that is a trap, right? So similarly, regarding the GATE exam, okay, whoever faculty is preparing for the questions for the GATE exam, if they are so expert, then they used to keep the wrong choice because of the silly mistake. Whatever the wrong choice you may get, that particular answer they will keep intentionally in the first choice, so that most of the students who are not having good knowledge, okay, they used to like catch out, right? So that is the reason here in option A, that is the trap, that 1 kHz is not the correct one, right? Now obviously 2 kHz is the correct one, but how it is correct, now let us see carefully. Just carefully observe. Here if you observe carefully, regarding x of t signal, they have given the waveform like this. They have given the waveform like this. Now you can observe carefully. Here you are having center frequency 0. Okay, from here after 1 kHz, you are getting one peak, right? And similarly from 0 here towards negative frequency side, okay, after 1 kHz you are getting the peak. You are getting the peak. So that means from minus 3K to 0 kHz, from minus 3K to 0 kHz, you are having band of frequency 3 kHz, just like here. This is also 3 kHz bandwidth, band of frequencies, this is also 3 kHz band, but there is a slight difference. Here from 0 after 1 kHz you are getting the peak, right? But here from 0 towards left hand side, when you have considered 1 kHz, there you are getting the peak. Just like here. Here it is like 1K, here it is like minus 1K. Okay, because here it is a continuous waveform. But the same logic you can apply now. If you apply that logic, then there is no problem at all. Here you are having band of frequency starting from where? 0 to 3K. But now what I have told, here we have to consider from 3K to 3K, we have to subtract 1K. 3K minus 1K. So that is nothing but 2 kHz. Okay. So here you are having two band of frequencies. One band of frequency starting from 23 and up to 26. There we have to add 1. 23 plus 1, that is 24. And here you are having band of frequencies 0 to 3K. So from 3K you have to subtract 1K. So from there you will get 2K. So for this question, the correct answer is option B. I hope it is clear for everyone. If you are having any doubt, okay, later in your free time, try to draw the spectrum. Okay, try to draw the spectrum for each and every output stage. From there, definitely you can choose option B without any silly mistake. Okay, right. I hope it is clear for everyone. So all of you give a try. The next question, which is asked in GATE EC in the year 2000 for 2 marks. Yeah, this is the question asked in GATE EC 2000 for 2 marks. Here you are having the message signal m of t, which is band limited to the frequency FM. That means regarding the message signal, the operating frequency is FM, right? And it is having the power, they have mentioned P suffix m. The power of the modulating signal or message signal is P suffix m. Now the question is, the power of the output signal in the given figure is dash. Okay, regarding that you are having 4 choices, you can choose the correct one. So here if you observe the given block diagram, here you are having the multiplier, for this particular multiplier you are having one input as cos omega naught t plus theta, whereas the other input is m of t into cos omega naught t, m of t into cos omega naught t. So when you have look at this particular expression, this is nothing but what? It is the DSB-SC signal, yes or no? You are multiplying the message signal with the carrier signal, that is nothing but DSB-SC signal. That DSB-SC signal, and at the receiver you are using carrier signal, but it is having some phase difference, right? So these two signals we have given as the inputs for the multiplier. That output we are passing through low pass filter. Which is having the cutoff frequency FM. That means whatever the modulating signal frequency you are having, okay, the same frequency we have given as the cutoff, so that means we are extracting the modulating signal or message signal at the receiver. So that means this particular block diagram is nothing but demodulator for of DSB-SC signal, yes or no? Demodulator of DSB-SC signal. And here regarding the low pass filter, it is having the pass band gain as 1. Okay, sometimes in some question they can mention other than 1, according to the requirement they can mention 2 or 3, etc., right? So whatever the gain they have mentioned, accordingly we have to consider. Okay, in some questions if they haven't mentioned regarding the gain, by default you can consider gain as 1. But if at all if they have strictly mentioned, okay, whatever the gain they have mentioned in the question, strictly we have to consider. Okay, right. So here they have given note point also, omega naught greater than 2 pi FM. So that means omega naught greater than 2 pi FM they have given. So here omega naught you can write as 2 pi F naught, which is greater than 2 pi FM. So here 2 pi will get cancelled. From here you are getting F naught is greater than FM. So here F naught is what? Carrier signal frequency. F naught is carrier signal frequency and FM is the modulating signal frequency. Okay, always we will consider the carrier frequency only greater when compared to the modulating signal frequency. Okay, right. That point only they have mentioned as a note, right? Now first of all consider output of multiplier. Output of multiplier. Output of multiplier, for the time being I am representing as S of t. Okay, output of multiplier I am representing as S of t. Here m of t into cos omega naught t, that is one input. M of t into cos omega naught t, that is one input, whereas the other input is cos omega naught t, cos omega naught t plus theta, right? So here you are getting cos A cos B format, right? So multiply and divide with 2, So for the time being I will write this term first, 2 cos A cos B, and this term I am writing here, that is cos omega naught t. 2 cos A cos B is nothing but cos sum plus cos difference. 2 cos A cos B is nothing but cos sum plus cos difference. cos sum omega naught t plus theta plus omega naught t, cos sum plus cos difference, omega naught t plus theta minus omega naught t. Okay, here omega naught t will get cancelled, So from here you are going to get m of t by 2, here omega naught t plus omega naught t, 2 times you will get cos 2 omega naught t plus theta, 2 omega naught t plus theta plus cos theta. So this is the signal that you are going to get at the output of this multiplier. At the output of multiplier, you are having two terms. Okay. So in the first term, you are having m of t by 2 into cos 2 omega naught t plus theta. Whereas other term you are having m of t by 2 cos theta. Now this particular signal we are passing through low pass filter. And it is having the cutoff frequency FM. So that means, as the name implies, low pass filter allows only low frequency signals starting from 0 and up to the cutoff frequency. Here in this particular example, in this particular question, the cutoff frequency is FM, right? So now can you tell among these two terms which term this low pass filter will allow and which term it won't allow? All of you please respond. Among these two terms, which term low pass filter will allow? See here, if you observe the second term, you are having m of t by 2 cos theta. Here cos theta is what? Constant, and 1 by 2 is the constant, right? M of t is the signal which is having the frequency FM, So that means this particular signal it will pass. This particular term it will pass. What about the other term? Here you are having 2 omega naught. Okay, in the question itself it is mentioned omega naught is greater than 2 pi FM, right? So here you are having 2 omega naught. It is having very high frequency, and of course here you are having m of t. It is having FM. So from there you are getting the frequency very high. Yes or no? When you are adding, you are getting like omega naught plus omega m, and similarly if you are considering like difference, okay, either of the two frequencies which are very high only when compared to FM. So that means the first term it is not passing, only the second term it is allowing, right? So the output of low pass filter is equal to, here we are getting the second term, that is m of t by 2 into cos theta. M of t by 2 cos theta. Now what is the question? Here up to now we got the output signal. Okay. Here they haven't asked regarding the output signal expression, but what they have asked? They have asked the power. What is the power of the output signal? Okay, regarding that you are having 4 choices, you can choose the correct one. So here if you are having only the modulating signal, okay, regarding that in the question they have mentioned the corresponding power is P suffix m. Okay, and for this modulating signal, suppose if you are having some constant k, if the modulating signal is multiplied by some constant k, now can you tell what will be the power? Yeah, whatever the constant you are having, just perform square of that one. That means k square. And regarding modulating signal, the power is same, Pm, P suffix m. Okay, now if you carefully observe, here you are having m of t by 2 cos theta. For the time being I am writing like this, 1 by 2 into cos theta into m of t. Now carefully observe, whatever the expression here you got, that one only I have arranged like this, 1 by 2 cos theta into m of t. Here theta is the phase angle, okay. So you will be having some fixed value, right? So that means cos theta is the constant, and 1 by 2 is also constant, right? So that means this overall term is constant, just like constant k earlier term, right? So you are having similar format, k times m of t. So that means k square into pm, So here whatever the constant you are having, just perform square of that. So 1 by 2 whole square, that is nothing but 1 by 4, and cos theta whole square, that is cos square theta. And regarding the modulating signal, the power is Pm. So this one, if you want, you can represent like this, Pm cos square theta divided by 4. Pm cos square theta divided by 4. Right. Now you can choose the correct option. Pm cos square theta by 4. Yes, option D is the correct. So whatever the block diagram they have given, we have considered step by step and we have done the simplification, right? So from there, since in the question they asked regarding the output, whatever the signal that you are going to get, regarding that particular signal they asked you to calculate the power. Okay, so the final answer for this question is Pm cos square theta by 4, that is option D. All of you try the next question. This is a similar one. Similar question. All of you try. Here they have given DSB-SC signal, DSB-SC modulated signal, that means DSB-SC signal, right? So here if you observe, m of t is there and AC cos 2 pi FCT, that is nothing but carrier signal. Message signal we have multiplied with carrier, that is nothing but DSB-SC, that's all, right? And this particular signal they have multiplied with local oscillator output. So here you are having carrier signal like this, cos 2 pi FCT, that means same operating frequency, but there is a phase difference. But here you are having 8 is the carrier signal amplitude, but here carrier signal amplitude is how much? 1 only, right? So there is a slight difference regarding the amplitude of the carrier signal and the phase angle of the carrier signal that we are using at later stage, right, when compared to the carrier signal that they have used at the transmitter section, right. Now the question is, whatever after multiplying these two signals, whatever the output that you are getting, that output they have passed it through low pass filter. And now in this question it is mentioned that the bandwidth equal to that of the message signal, that is M of t, message signal M of t. See, the previous question they have given, in the question they have given the block diagram, right. So in this question, without giving the block diagram, everything they have mentioned in the question itself, right. So if you read the question carefully, sentence by sentence, from there you will get the visualization. If you are able to visualize in terms of the block diagram, you will get similar block diagram just like the earlier one. You can observe here you are having like M of t into cos omega naught t, that is nothing but what? Your DSB-SC signal, and that signal we are multiplying with the local oscillator. Okay, after that we are passing through low pass filter. Here they have directly mentioned the cutoff frequency FM. That FM is nothing but the message signal or modulating signal frequency only. Okay, right, and then you are getting the output signal, and for that output signal we are calculating the power, right. Now just see this question, without mentioning the diagram, they have given the same sentences or similar sentences. Okay, but if you are, after reading this question, if you want to draw the block diagram, what is the block diagram that we have discussed in the last question, similar block diagram you will get. Okay, and here they have mentioned low pass filter cutoff frequency as bandwidth of message signal, that is nothing but whatever the message signal modulating frequency that you are going to get, FM, the same FM is nothing but the low pass filter cutoff frequency. Both are same. Whenever you are having baseband signal, okay, the bandwidth or highest frequency both are same, right. And here in this question it is mentioned theta value as 45 degrees. Now here also you are supposed to calculate the power only at the output signal, but now this power at the output you have to mention in terms of the input power. In terms of the input power means message signal power here. Okay, whatever original modulating signal we are having, for that modulating signal power, okay, you will calculate, or you can assume just like the previous question, you can mention like P suffix M, right. So now you have to calculate the power at the output. That expression you have to find out in terms of the message signal power, right. So from there you will come to know how many times it is, that's all. Okay, so that means this question is also similar to the earlier one. The only difference, in the earlier question we are having the block diagram, but here we don't have the block diagram, but rest everything is the similar procedure. So here initially you are having S of t signal, and then you are having carrier signal, and these two signals we are multiplying. So S of t into C of t. S of t into C of t. Here 8 M of t cos 2 pi f c t into cos 2 pi f c t plus theta. Cos 2 pi f c t plus theta. So theta value if you want you can substitute 45 degrees. Just if you want to do simplification quickly you can substitute, right. Here also it is like cos A cos B form, so you can multiply and divide with 2. Otherwise here you are having 8, so for the timing 8 you can write as 4 into 2. So here we can write 4 M of t into 2, this term I am writing first, cos of 2 pi f c t plus 45 degrees, and then this term cos 2 pi f c t. Now it is in the stand form, 2 cos A cos B, so which is nothing but cos sum plus cos difference. 2 cos A cos B is nothing but cos sum plus cos difference. So here when you are adding both, 2 pi plus 2 pi, that is 4 pi. So you'll get 4 pi FCT plus 45 degrees. 2 cos A cos B is equal to cos sum plus cos difference. Cos difference. 2 pi FCT, 2 pi FCT will get cancelled. You will get 45 degrees. 45 degrees. Now, first term you can copy as it is. Second term you can do the simplification. Cos 4 pi FCT plus 45 degrees plus cos 45 is nothing but 1 by root 2. Sin 45, cos 45 both are same, 1 by root 2. Okay, right. So this is the signal you got after doing the multiplication of S of t and C of t. Now this particular signal they have passed through the low pass filter. Low pass filter, and it is having the cutoff frequency. It is having the cutoff frequency FM. It is having the cutoff frequency FM. Okay. Now if you observe, just like the previous question, this is the very high frequency component, whereas the other term if you observe, you are having only the modulating signal, right? 4 m of t by root 2, that's all. So that means low pass filter won't allow this particular term, it will pass only the second term, right? So output of low pass filter will be 4 m of t into 1 by root 2. So that means 4 by root 2 m of t. Now the question is, you have to calculate the power, right? So just like the previous question, here we have mentioned, if you are having only the modulating signal, the corresponding power you will get Pm, power of the modulating signal. Okay, and if you are having constant times modulating signal, then the corresponding power will be k square times Pm. So here the constant is 4 by root 2, right? 4 by root 2 is the constant times you are having modulating signal. So the corresponding power you will get, just perform square of this one. 4 square is nothing but 16, divided by root 2 whole square is nothing but 2 into m of t power is Pm. So 2 8 times, so that means you are getting 8 times modulating signal power. Now if you read the question, now you got the answer. They have asked power at the output of low pass filter is dash times the power of the message signal power. So the answer for this question is 8. Okay. So the previous question and this question, we have solved the question in the conventional approach. We have used the mathematical equations whatever they have given, and we have used the standard trigonometric equations. From there we got the answer. Okay, whatever the approach we have discussed in both the questions, this approach is the conventional approach. For understanding purpose, I have solved the question completely. But these two questions you can easily answer without using pen and paper. How? Some of you might be wondering, sir, how we can solve these two questions without using pen and paper? Because we have done so much calculation or derivation, whatever required, okay, but without using pen and paper, how to attempt these two questions, right? So now see the beauty here, see the magic here, how we are able to answer without using pen and paper. Whatever the calculation required, that calculation will be simple. That simple calculation you can do in the mind, okay, right? So just observe here. So just observe here. Yeah. So this is the block diagram they have given. So here at the output of first multiplier, you are just multiplying these two. Yes or no? So when you have multiplied these two, here you are getting the format like cos A cos B format. Okay. But you are having the standard trigonometric equation like 2 cos A cos B format. For that, we are multiplying and dividing with what? 2. Okay. After that, when you have applied the standard trigonometric equation 2 cos A cos B, we are writing like cos sum plus cos difference. Cos sum plus cos difference, right? So now after that, what you are having? So here first and foremost observation point is whatever the multiplied signal you are having, whatever the multiplied signal that you are getting initially, if you are having 2 times in that particular expression, if you are already having 2, okay, so you have to divide with 2. If 2 is not there, still you have to divide with 2. Why? See, if already 2 is present, then there is no problem. 2 cos A cos B, you will write cos sum plus cos difference. M of t only you will take. But here you don't have 2. Whenever you don't have 2, okay, you can divide and multiply with 2. So that you are getting the standard equation 2 cos A cos B. If 2 already present, then there is no need of doing division, right? Yes or no? Correct. So here first and foremost observation point is this one. Since you don't have 2 here, okay, but you are getting like 2 cos A cos B format, in order to get like that, we are multiplying and divide with 2. So because of that, the first factor that you are getting, whatever the modulating signal you are having, that is getting divided with 2. Okay, this is the first and foremost observation point, right? And after you are applying the standard trigonometric equation, you are getting 2 functions. Okay, here both are cos. Okay, sometime you may get one is sine, another one is cos, or maybe both are sine, whatever it may be. But in the internal terms, if you observe, in one of the term you are getting addition of both, in another term you are getting difference of both. Yes or no? Right. Now when you are adding both, that means this overall frequency that you are getting very high. But whereas here when you are subtracting, the high frequency component is getting eliminated. So that means you are getting what? Here cos theta. Cos theta is what? Simply constant. And here whatever 1/2 you got, that is also constant. And simply you are having what? M of t. So whatever the signal you got, there you are having 2 frequencies. One is addition of those 2 frequencies, another one is subtraction of those 2 frequencies, right? So since this particular signal we have passed through the low pass filter, that means the high frequency component is getting eliminated, only the low frequency component you are getting. So that means final conclusion point is what? Here first and foremost observation point, in the given whatever the multiplier output you are having, in that particular signal, if you don't have 2, okay, you have to divide with 2. Simple. That is the first observation point. And then whenever you are using any trigonometric equation, if both are cos or both are sine, or one of the 2 terms is sine, another one is cos, okay, then according to what are the standard formulas, you will get the 2 terms, okay, in terms of sine or in terms of cos or in terms of sine and cos, whatever it may be. But one of the frequency you are going to get addition of 2 frequencies, and other term you are going to get difference of 2 frequencies. Whenever you are passing through low pass filter, you will get the low frequency component. That means high frequency component is getting eliminated, right? So here you are getting cos theta term. So just observe simply whatever the 2 terms you are having, just observe and just consider difference. Here omega naught t will get cancelled. You are getting simply cos theta. That's all, cos theta, right? So, but whatever the standard formula you are using, that you have to just recall. Here you are going to apply 2 cos A cos B, that means cos sum plus cos difference. So that difference here you are going to get cos theta. That's all, right? So this much, this is the first observation point, right? So that is the final output you got. That's all. M of t by 2 cos theta. Yes or no? Now regarding m of t, the power is Pm, but here cos theta is constant and 1/2 is constant. So what is the constant you are having, that is getting power 2, right? Or simply you can perform square of that constant term, and then regarding m of t, as usual, the power is Pm. That's all. How much time it will take? So just observe the given question, how much time it will take. Here you are applying like you are multiplying these two. Okay, both are cos signals, so that means 2 cos A cos B means cos sum plus cos difference. So finally you are going to get cos theta, right? Here 2 is not there, so you are dividing. So m of t by 2 cos theta, right? So cos theta by 2 is a constant, so that means cos square theta by 4. Regarding m of t, the power is Pm. That's all. How much time it will take? It won't take much time, right? You no need to do, you no need to use pen and paper, right? That much easy, that much easy. Similarly, with this understanding, all of you give a try. What are the approach just now we have mentioned? With that approach, just all of you give a try. Here in this particular question, we are multiplying S of t and C of t. S of t and C of t we are multiplying. Okay, here 8 is there. Here 8 is there. Okay, so 8 we can write as 4 into 2. 8 we can write 4 into 2. So that means we are getting that 2 cos A cos B format. 2 cos A cos B format we are getting, right? So that means here we are having like 4 into m of t. 4 into m of t. Okay. So whenever you are having 2 cos A cos B, that time you don't need to divide with 2. Okay. Whenever you don't have 2, then only you can multiply and divide with 2. I hope it is clear for everyone. Now once again 2 cos A cos B means cos sum plus cos difference, right? But here also you are passing the signal through the low pass filter. That means whatever the low pass signal or low frequency signal that you are going to get, that only you will get at the output of low pass filter, right? So here also you have to consider only difference of these two. So 2 pi fct will get cancelled. So you are getting cos theta. Yes or no? Cos theta. But here theta value they have mentioned 45 degrees. Theta value they have mentioned 45 degrees. So cos 45 is nothing but 1 by root 2. So that means you are getting 4 by root 2 times m of t. So for m of t the power is pm. So for constant time m of t the power will be 4 by root 2 whole square pm. So here 4 square is 16, root 2 whole square is 2. So 16 by 2 is 8. Here understanding purpose I have written the steps, but all this calculation you can do in the mind. Yes sir. Here you are going to get 4 by root 2. Just perform square. 4 square is 16. Root 2 whole square is 2. 16 by 2 is 8. 8 times. That's all. No need to use pen and paper. I hope it is clear for everyone. So previously we have solved these two questions in the conventional approach for understanding purpose. Whenever you are solving any question, first try to solve the question in the conventional approach. After that, try to understand the solution. Okay, what steps you have done and what are the conclusion points. Just look at the question and observe the final points. From there you will get the clue. Okay, so when you're contemplating your solution, then you will get the shortcuts. Okay, if you are not contemplating, if you are just simply solving, that means you are doing laborious process. Yes or no? See, you may understand the concept, but in the GATE exam, whatever the concepts you have learnt, you have to apply those concepts. You have to attempt the questions in less time, right? So that is the reason initially if you are learning any subject, try to learn the subject step by step, try to solve the questions in conventional approach, but later whenever you get the opportunity to solve the same question, okay, try to solve the same question by using shortcut method. So that what will happen, if you are able to solve the same question in less time, so because of that in the GATE exam you can attempt more number of questions correctly, so that your score you can increase, right? So that is the reason always first focus on the conventional approach. With the help of conventional approach you will get the basics. You can become the strong on your fundamentals or basics about that particular subject. Once if you get the enough command over the concepts, then try to solve whatever the questions you might have solved earlier. Try to think whether I can solve the same question in less time, whether I can solve that same question by using any shortcut approach. When your mind is like parachute, okay, if you are keeping your mind like open, then ideas will come. Nothing is impossible, right? So all of you give a try. Okay, whatever possible at that particular time and circumstance. Sometime you may get the thought in order to solve, for solving that particular question, you may get some ideas or methods, right? Sometime may not possible. Okay, no problem at all. But later, over a period of time, if you are increasing your knowledge day by day, then definitely there is a scope to get the shortcut methods, right? So regarding communication subject, generally students will think that whoever EC branch, generally students will think that among EC subjects, EDC, analog, communication, EMT, generally students used to think that these are the tough subjects or difficult subjects. Okay, there is no word like tough or difficult. It's a matter of how much interest you are having and how much eagerness you are having in order to learn the subject. That's all. Okay, see, why you are feeling that the subject is tough, the reason is due to lack of knowledge. Okay, once if you are having good knowledge, enough knowledge, and if you are having fundamentally strong, and if you are having interest, then definitely all the subjects, if you are from EC, you are having total 10 subjects, right, in the GATE exam. So all the 10 subjects you will feel that all the 10 subjects are easy. It's a matter of how much interest you are having. It's a matter of time. That's all. Okay. So the moment if you are getting the knowledge and enough knowledge and good knowledge about the concepts, if you are learning the concepts crystal clear, then no matter whatever the subject name, you might have thought that it is a tough subject or difficult subject, but over a period of time you only will say that, sir, this is a very, very easy subject. Okay, so that much feel you can get. Okay, because all these subjects, you are not studying any mechanical subject, right? So say for example, if you are from EC, you are not studying any civil subject or you are not studying any mechanical subject. You are studying your own branch subject only, right? So initially you can try to study subject by subject in the sequence from the basic subjects, then slowly advanced subjects. Then once if you have completed all the subjects in a sequence, then at last you have to consider all your subjects together like only one branch, or you can consider like only one subject, that is EC. That's all. You should not do any distinguishing. Okay, while you are attempting the paper, you should not distinguish whether this question is EDC or whether this question is analog, whether this question is EMT or communication. No, not like that. While you are learning the subject, while you are learning the concepts, then you are having the segregation. These are the 10 subjects. But while you are attempting, you should consider all the 10 subjects together as a single subject. That is related to EC. That's all. EC. Right? Right. So next question, this is the NAT. All of you give a try. Yeah, first of all, read the question. Here you are having DSB-SC modulation. It is used by a communication system having the message signal as sinusoidal signal and carrier signal as 2 cos omega ct. 2 cos omega ct. Now they have used the synchronous detector. Okay. So whenever you are using the detector or demodulator, so for that particular circuit, okay, the input signal is nothing but the modulated signal. So that if you are passing the modulated signal through a detector or demodulator, from there you can extract the message signal, right. So here you are having the synchronous detector which is used to detect the message signal or modulated signal. Now regarding this, in this particular synchronous detector, we will use one local oscillator frequency, but it is having the phase shift of 60 degrees between the transmitter and receiver carriers. Okay. In the transmitter section, you have used the carrier signal which is having cos omega ct. Here there is no phase shift, but at the receiver you have used the same signal, but there is a phase shift of 60 degrees. Okay. Now the question is, what are the output that you are going to get at the output of synchronous detector, right? So in that particular output signal, the what are the final expression that you are going to get? Okay. So there you will get in terms of m of t, so that m of t multiplied by how much factor? That is the question. Okay. So regarding synchronous detector, I hope all of you are familiar. Whatever the previous questions we have discussed, okay, if you observe this block diagram, this is nothing but synchronous detector. So in the synchronous detector, you will be having multiplier. So for that multiplier, you are having two signals. One is the modulated signal, that is nothing but DSB-SC in this example, and the other one is the locally generated carrier signal, right? So according to the question, you are having the phase shift between the carrier signal which is present at the transmitter and which is present at the receiver, right? And then what is the signal that you are going to get? That you are passing through low pass filter. Okay. So regarding that, we already solved the two questions earlier in the conventional approach. After that, I have given the hint. Okay. The only difference between the previous questions and the current question, earlier they have mentioned the block diagram, or they have given regarding those blocks in the sentences, but here in this particular question they haven't mentioned regarding the block diagram, they haven't mentioned regarding the components, but they have mentioned the synchronous detector. See here, if there is no phase difference, between these two carrier signals, that means the carrier signal that you are using at the transmitter and the carrier signal that you are using at the receiver, both are in synchronous. That is the reason whatever the detector or demodulator that you are using in order to extract the message signal, okay, so the name of this particular circuit is nothing but synchronous detector. Okay, whenever there is a phase difference, okay, so according to that particular phase difference we will consider, but the detector wise, synchronous detector means you are having mainly two components. One is multiplier, another one is low pass filter. Okay, for that multiplier you are having two input signals, one is modulated signal and the other one is locally generated carrier signal, right? I hope it is clear for everyone. So this is the main conclusion point for this question to solve. Okay, since you don't have the block diagram, or since they haven't mentioned what are the main components that required within the synchronous detector. Okay, those who have studied regarding communication subject, okay, they're having some idea, right? In the synchronous detector, what are the components you're having. But whoever students are learning communication system subject very first time, so for that I have shown the synchronous detector diagram that is already present in the earlier question. In one question they have mentioned the block diagram, in another question the same thing, instead of mentioning the block diagram they have represented in the sentences, right? Everything they have given, right? So here the main important point in this particular question is regarding synchronous detector. So for the timing I am not drawing the diagram, but I am mentioning what are the conclusion points we have discussed regarding synchronous detector. So in the synchronous detector we are having two components mainly. So one is multiplier or product modulator, both are same, and then we are having low pass filter, Hi, good evening, BKM. So here first of all, the previous two questions we already solved in the shortcut, right? First we explained in the conventional and then I have discussed the shortcut. So for this question also, if you want to solve the conventional, you can try in later whenever you get time. But for the time being, I will solve in the conventional. For the timing, I will solve in the shortcut approach because we already solved two questions in the conventional approach, right? So just observe here, you are having the modulating signal or message signal, that is m of t for the timing. If you consider m of t, okay. So first of all, I am writing the s of t signal, that is a DSB-SC signal. So which is having message signal m of t, and then carrier signal you are having 2 times cos omega ct, 2 times cos omega ct. So this is the DSB-SC signal that you are giving as one of the input for multiplier, right? The other input is locally generated carrier signal. The other input is locally generated carrier signal. So here whatever the carrier signal you are having, the same carrier signal, but it is having a phase shift of 60 degrees. It is having a phase shift of 60 degrees. So for the timing, I am considering like C1 of t. C1 of t. So whatever the carrier signal you are having, same thing you can consider 2 cos omega ct, but it is having a phase shift of 60 degrees. Phase shift of 60 degrees. So these two signals we are giving as the input for multiplier. These two signals we are giving as the input for multiplier, right? So here if you are multiplying both, okay, when you are multiplying both, what you are going to get? You will get output of multiplier, I am writing output of multiplier. Here you are having, for the timing I will represent like this. Why I am writing like this, you will come to know shortly. 2 times m of t into 2 times cos omega ct plus 60 degrees into cos omega ct. Just carefully observe. Here 2 times m of t is there, yes, 2 times m of t is there, 2 cos omega ct plus 60, same, and then cos omega ct. Okay, now just observe, here you are getting what? 2 already is there, right? 2 cos A cos B. So that means here you no need to divide with 2, yes or no? 2 cos A cos B. So that means this term we will consider, okay, 2 cos A cos B, that means cos sum plus cos difference, right? So cos sum means you are getting high frequency component, cos difference means you are getting here omega ct will get cancelled, you will get cos 60. So 2 times m of t into cos 60, that is a low pass signal or low frequency signal. So when you are passing this particular overall signal through the low pass filter, at the output of low pass filter, you will get the term like this. Output of low pass filter you will get 2 times m of t, 2 times m of t into cos 60 degrees. Cos 60 degrees. So cos 60 is nothing but how much? Cos 60 is nothing but how much? 1 by 2. Yes or no? Cos 60 is 1 by 2. So here 2 will get cancelled. So finally you are getting m of t. Yes. So at the output of low pass filter or at the output of synchronous detector, finally you are getting m of t. So here if you observe m of t multiplied by 1 if you want to consider, yes or no? Suppose if you have got like 2 times m of t, so that means multiplying factor is 2. Suppose if you have got like 8 times m of t, okay, so that means multiplying factor is 8. So now just look at the question. Here at the output of synchronous detector, you are getting a signal. In that particular signal, the message signal is multiplied by how much? That is a question. The answer for this question is 1. Answer for this question is 1. I hope it is clear for everyone. It is very simple. You can easily solve. In the last class also we have solved variety of questions regarding DSB-SC without using pen and paper. Okay, similarly here in this particular session also we have discussed various questions regarding DSB-SC, especially regarding the detection or demodulation. Without using pen and paper, you can easily solve. Once if you are having the idea in the mathematical approach what we are doing, at last if you observe the conclusion points with respect to the given question, from there if you observe directly what are the conclusion points are there, if you apply those conclusion points directly, then you can solve easily regarding the DSB-SC questions and regarding DSB-SC demodulation also without using pen and paper. Okay, so first of all the two conclusion points are important. Whatever we have discussed, I am repeating once again. The two conclusion points are, whenever you are having synchronous detector or demodulator in order to get the modulating signal. Okay, so especially when you are having the one of the signal as DSB-SC, and the other signal is the locally generated carry signal. So after doing the multiplication, whether you are getting 2 in that overall term or not, first of all cross check. If 2 already is there, you no need to divide with 2. If 2 is not there, you have to multiply and divide with 2, so that what will happen? Here you are getting like 2 cos A cos B format. Okay, so once if you are getting like 2 cos A cos B, and in some questions you may get like 2 sin A cos B or 2 sin A sin B or something like that, right? All the 4 possible ways. Accordingly you will get 2 terms, right? Either both the terms are like sin or both the terms are cos, or one term sin, another term cos, etc. But if you observe both the terms, in one of the term you will get like addition of these two, and in another term you will get subtraction of these two. So whatever the multiplier signal you are getting, that multiplier signal through what filter you are passing. Here you are passing through low pass filter. So whenever you are passing through low pass filter, you can focus only the low frequency signal, that's all. High frequency signal you can ignore. So from here, suppose here we have considered the phase shift as 60 degrees, but if there is no phase shift, that means cos 0 is nothing but how much? 1. So simply you are getting this much, that's all. Okay, right. So that means final conclusion point is, first of all you have to observe when you are multiplying the signals at the output of multiplier, whether do you have 2 or not. If 2 is there, then no problem, then directly you are applying the standard trigonometric equation. If 2 is not there, multiply and divide with 2. That is the first observation. And then according to the trigonometric equation, you can apply, and from there you are getting 2 terms. Among those 2 terms, whichever frequency is having low, that frequency only, according to the cutoff frequency of the low pass filter, you can check and it will be passed. Okay, so that particular cos theta term you are going to get here, that's all. After that, in some question they will ask only the output expression, in some question they will ask the power calculation, etc. All the variety of questions we have discussed in this particular session and in the previous session also regarding DSB-SC, right? So I hope all of you got lot of enlightenment, lot of inputs, lot of concept clarity regarding the DSB-SC. Okay, so in the one of the upcoming session we'll discuss one more question regarding DSB-SC, and then we'll discuss the questions related to SSB-SC. So thank you everyone, we'll meet you all in the next session.